First thing I recommend you do is put your two atoms that you have up here and just mark out their valence electrons so you know what you're working with. So how many valence electrons does carbon have? 1. Good. What about hydrogen? 1. All right, great. Okay, so we have this. Next thing, out of these two, which one's more likely to be the central atom? Carbon. Carbon. All right. So we're going to have carbon as our central atom. Now, there's 7 carbons. So what do you think is going to happen with all these carbons? They're all going to be in a line, right? They're all going to connect. Yeah, it's a great idea. So let's draw that out. 1, 2, 3, 4, 5, 6, 7. All of their dots. Okay? And then we link them all together at least once, right? I would recommend you do that first. Don't try to do any double bonding or anything. Just connect them because you might not need any double bonding. Okay? And then how many dots do we have left here? 16. 16. Okay. How many hydrogens do we have? 16. So guess what we do? Bond them. Exactly. Yeah. Everywhere there's a single unpaired electron, we're going to add a hydrogen. And you're going to painstakingly watch me do this 16 times. And then we're going to connect them all together. Whoops. Look at that. Messed up. Right now. Oh, that was a mess. All right. And then we connect them all. In here. All right, now, let's talk AXE. All right, what's the AXE for this? Okay, so I heard AX3, I heard AX4. Let's circle out one of the central atoms first. I'm gonna pick the first carbon. How many hydrogens are around this one? 3. Yep, so we have 3. Is there anything else directly connected to this carbon? One other carbon, right? So for this one, it's AX. Pattern is going to be AX4, yep. Which means the shape is tetrahedral, and the angle is good, 109.5. What about the other carbons? They're all the same, right? Instead of writing it a million times, just draw some arrows. All right, they're all going to be that. And every time you have a hydrocarbon with only single bonds, it's going to be like this. You get double bonds and triple bonds, things are going to change. But if it's a hydrocarbon and it's all single bonds, it'll always be all tetrahedral. Okay? Good? Cool. Any questions? Oh, Brian, yeah.
Is it okay if we do an isomer of that?
Oh yeah, that's great, an isomer. How would you have drawn it?
I did it in a cross.
Okay, all right, so let's check this out. So we would have, how many carbons do you have across?
5.
5, all right. 1, 2, 3, 4, 5. They all have their dots around it. Okay, and then these are all bonded together. All right, and then where'd you put your other ones?
I put them on top and below the middle seat.
Okay, so the third one, we put another carbon up here, carbon down here. And then we connect them. And then how many single dots do you have there?
16.
16, okay, yeah, and then we put hydrogens around it, and that would be perfect. Yeah, so this would work out great. Now, while I'm filling all this in, check for the AX pattern. Is it still AX4? Yeah, it is, right? Again, it's all single bonds, it's all hydrocarbons, it's gonna be AX4. And just to check that, just look at any of them. There's 4 things connected to every carbon in here, so that works as well. All right? Any questions on that? I know it looks messy, but that looks great.